Dear friends, welcome back to the channel. Today we'll be diving into another fantastic machine on the Vulnhub, which is Sunset Dawn2. The link will be put in the video below so that you can download it and play it on your own. This is a very typical buffer overflow machine. However, please don't panic. I will demonstrate every step for you. Before we get started, make sure to subscribe to my channel and give this video a thumbs up. It really helps the channel grow. So now, let's head over to Linux to begin with. First of all, we need to discover the IP address of the target machine. The utility I'd like to use, as always, would be net discover. So as you can see over here, this IP address belongs to the target machine or victim machine. And the second one, since this machine involves Windows 32-bit buffer overflow, and to make our exploitation easier and convenient, I deployed this Windows machine, Windows virtual machine. Okay, so now let's go back. So what shall we do next? We need to perform port and safe scanning with a map. To save time of this video, I've already completed before. So now we can get out its result. So as you can see over here, I took the options like scene scan, the version scan, default script scan, and then full range port scan. The last option for all is ON to output the result into this file. From the map scanning results, we can tell the target machine has 3 open ports. Unfortunately, the map cannot determine the exact service information for the last 2 ports. Okay, so what are we going to do next? We need to emulate this web application both manually and automatically. Let's fire up the browser. To perform manual emulation first, we can put the IP address of the target machine into the address bar of the browser. Press enter. So website currently under construction. Try again later. However, in the middle of this page, we notice this hyperlink. We can download the dawn server. Okay, we can click. Okay, it's downloaded, and then we can move from downloads directory to current working directory, and we can unzip this file done. Okay, so apparently this is the Windows executable. You can use the file command to get more clear information. So this is for Microsoft Windows. This is the 32-bit executable. And just I mentioned earlier, we need to transfer this executable to Windows because I'm going to launch Immunity Debugger to help us to conduct buffer overflow. Okay, but before we go there, I'd like to complete the web emulation. Okay, for example, let's go back to the browser, and I'd like to check its source code. Of course, we can't find anything useful from this source code. Next, I'd like to check to see whether this site has robots file or not. Next, we can launch Nicto to perform comprehensive web emulation. If you try to emulate web application, you cannot miss this utility Nicto. Even sometimes with this utility, we can get very useful results. Okay, but it's not this case. Next, we can launch GoBuster to perform directory emulation. debugger, directory, extension option. So now GoBuster starts its immersion. Directory immersion. Although GoBuster can support other types of immersion like a virtual host. Okay. Anyhow, GoBuster can't find anything else. Okay. To save time of this video, I'd like to interrupt it here. So I think what are we going to next? We need to transfer this Windows executable 32-bit to Windows virtual machine. Okay, and I've already done that before. Yeah, this one. I think no, not this one. Yeah, where? Oh, here. Okay, and also there is textual file we can open up. So important due the lack of implementation of the dawn client, many issues may be experienced, such as the message not being delivered. In order to make sure that the collection is finished, blah, 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 and the service may crash after several requests. Sorry for the inconvenience. Okay, so how to do? Let me open as administrator, run it. So it's running, and we can open another window. We can use netstat NOA. Okay, and this command will display all ports. So I think you can notice here. Yeah, this is the new port number. It's running, and just now the nmap scanning results told us this port number is open on the target machine. So I think this open port should be a collection to the dawn executable, okay, or dawn server. So how to do next? Next, we need to check to see whether this is vulnerable to buffer overflow. So how to do? Let me use Python to automate this process, okay? And I've already opened up this PyCharm editor. You can use any editor what you prefer, okay? So now we can import, maybe I can make the left window to be larger so you can see what's going on exactly. Import socket module. And also I like to import sys module. This module can handle users input and also can control the flow of our program. And also I'd like to import a time module. And we can initialize the object of the socket. So IP address version 4 address family socket sock stream. This is TCP, and we can connect to the target. This case is Windows machine. Okay, if we can, we can conduct buffer overflow successfully to the Windows machine, and then we can, move to the victim machine. Okay, or Linux, and the port number. Sorry, I can remember its port number. Yeah, we can copy and paste. We won't make a mistake, right? And we can define the variable size, which value is set to initially to set it to 100. Okay, and then we can use a while loop true, so we can send. But before we do that, I think we can use the netcat to connect to the target machine on this port number. Okay, so we'll receive response from the target machine, right? Oh, so it's maybe we need to run it again. let's go back to PyCharm editor. We can send, okay, the payload should be, I can use uppercase A, or we can use bytes format, size, and then we can send this payload to the target machine. Okay, send payload, and also we can print out something like sending data in how much or how many bytes, size, bytes, but we need to use the try loop, right? Try and except. So if any exception, we can print out something like something wrong at how much, size, bytes, and then we can close this collection, and then we can exit from the program, and then we can add 100 bytes. We can introduce a delay between each request, like 1. Okay, so I think that's all. Let's run our program to see whether we can find, or we can find whether this executable is vulnerable to buffer overflow. Okay, let's run it. Exploit. So sending 200 bytes, 400 bytes. It's broken. Okay, it's broken. So now I think, so next, just now we have to know the executable is vulnerable to buffer overflow. Next, we need to know the exact location or offset where the overflow happens. Okay, so how to do? We can use this utility to create the string or payload with particular pattern, MSF, and pattern create, and we can create 600. Okay, so now we can copy and we can go back to the PyCharm editor and put over here. So this should be payload. We need to use and size. It's not necessary, and also we can delete all useless code, and we can indent these lines. Send a payload. Okay, S. Oh, I think we need to receive, right? And S close. So now let's run it. So how to do? Let's go back to Windows machine to start this executable again, and then we can, oh sorry, I think to calculate or get the offset we need to utilize the utility Immunity Debugger, which is running on the Windows. Sorry about that. We can close up, and I'd like to open this Immunity Debugger, very powerful debugger, and we can make it maximum and open. This executable. So at the bottom, you can see at now is paused. The state is paused. We need to click this triangular button. And then at the bottom, you can see it's running. Now we can go back to the Kali Linux and run our exploit. Let's go back to Windows. Next, we can copy this EIP address. You know, EIP means extended instruction pointer, you know, which store the address of the next instruction. This is most critical register, and we need to, you know, put our address of a malicious code. Okay, so now we can copy. Sorry, can I copy? Copy selections, and we can copy, and I think we can stop it, and we can use another utility to calculate its offset. However, no exact matches. Actually, this is the, you know, the difficulty you will be encountering possibly. You know, as a matter of fact, we need to put the intercept or a 00, you know, or the bad character. Okay, and so how to do? We can put this 00, and we can save, and let's go back to Windows and run it again. Click, it's running, good. So now, how about we run this exploit again? Let's go back to here and copy this address. So this time we got a different address. We can copy and use this pattern offset to calculate its offset. So offset is 272. Fantastic, beautiful. We can note this number or figure over my notebook. So what can we do next? I think the payload, not necessary. So next, we can call it a payload. Should be the offset, and you know, EIP. So this part in this section is EIP, but for now I put B, uppercase B, and as before, we need to put this bad character or intercept 00 in order for this to work. Okay, so now we can save, and we can save. So now we can attach this executable again. So run exploit. You can see here, indeed, EIP has been overwritten by our uppercase B. You know, 42 in hex stands for uppercase character B. Okay, so what are we going to next? Next, we need to find the bad characters. Okay, so how to do? Let me go to the GitHub, and you can copy these bad characters. And I want to, you know, here, so put over here, bad characters, because I'm using the Python 3. So it will better put the bytes in the front of each line. If we send this payload, I mean the bad characters, to the target machine, and if specific character like this one disappear in the dump in the memory, and we think they should be bad character, and we should exclude this bad character when we create shellcode. Okay, so this is a very important step. Of course, always the 00 x00 is bad character, but we do not need to test. Okay, for every case, x00 is bad character. So now we can put the bad character chars. Okay, that's it. We can save. Now we can restart our executable, run it, and run this exploit by Python. So now let's go back. So next we can go to ESP. ESP, this is the stack pointer, and we can follow the ESP in dump, and you can check. Maybe it's not very clear. 1, 2, 3, 4, 5, 6, 7, 8, all the way to the F. All the way here. So as in every character, what should appear is there, right? So it means that we can't see any other bad characters except or besides 00. Okay, so good. So now let's go back to our Kali Linux. So next we need to create the shellcode. We can use the command of Metasploit msfvenom Windows, and let me auto-complete this command, but I'd like to use another port number 443. Okay, so now we can press enter. But before we construct our malicious payload, we need to find the EIP. We want the address, the instruction which is at this address to be executed. Okay, so how to do? We can go back to the Immunity Debugger. We can use one plugin, Mona, and modules. And we need to look for the module or executable or dynamic library, link library, which all security features are set to false, like this one. So I think this case is the dawn.exe itself. And next we need to find the address of a specific instruction, like a jump ESP. Okay, so now, but we cannot use the string jump ESP, assembly language. We need to use the operation code, and we can use this command. JSP ESP. Oh, sorry, GMP ESP. So this is the operate code, and we can use this one to search. We can use the search, find, and string xff xe4. The module name is dawn.exe. However, found 0 pointers. So it means that this binary, we didn't find the instruction of jump ESP, although this is a very common instruction for almost every executable. So we need to find other type of instruction of assembly. So how to do? Let's go back to the Linux. We can try to use the push ESP and IT. So I'd like to check to see whether we can find the push ESP and IT. Okay, so how to do? We can change FF to 44 C3. C3, okay. And we can press enter. Indeed, we find a pointer. We can copy this address and we can transfer to Linux. So this address should be put into EIP, and then shellcode after it can be executed. Okay, maybe I can put over here. So next we can copy this shellcode. We can copy. And let's remove this one. Okay, so the buffer. So next, the address. Of course, you know, a modern computer is using little India. We need to reverse this address. Okay, x77 x17 x58 x34. However, you know, this should be our buffer or shellcode. Okay, and we need to remove this times 4. However, we need to normally we need to put the long operation. Okay, 90, and we can put like a 20. So I think that's all. We can remove this one. Okay, so we can save. If this program can work, and then we can get, you know, we can conduct buffer flow and get the shell of the target machine. Okay. Now we can set up listener on the Linux, waiting for collection from the target, from the Windows machine, not the target in this case. Okay, so now we can run Python exploit. But it doesn't work. It looks like, right? Oh, sorry. I think we need to, you know, we need to run executable first, and we can run it. Run it again. You see, we successfully get the, you know, get a shell on the target machine. Beautiful. So now, just now, what we have done is to Windows virtual machine. We need to do the same to the victim, to the target machine. This is very easy. We just do some changes. For example, here, the IP address of the target machine should be 61, and also the shellcode would be different. So msfvenom. So this case, we need to change it to Linux, right? Linux x86, And I don't think in Linux it's necessary, so we can delete it. Now we can press enter. So we use the B option to specify the bad characters. Now we can copy and replace existing one. Okay, so that's it. We can save. So now we can, of course, we can set up the listener one more time, but this time we are targeting the victim. So now we can run exploit. We have already got a collection. Fantastic. And now we can spawn interactive shell by Python. Python 2 is there. pty spawn. Okay. Resource temporarily unavailable. So Python. What's wrong? Import pty spawn bin bash. Error. It doesn't matter. And we find, another better version of dawn service. And this executable is owned by root user. So next, we need to target this better version of dawn. However, we need to download it. So how to do? So the Python 3 is available, and we can set up a web server. So now we can go to the already used. Beautiful. So we can, but already used, it doesn't matter. We can specify different port number like 9000. It's okay. Because I didn't start from the scratch, from the fresh machine. So now we can download this, executable and transfer this to Windows machine. And, normally our threat protection of Windows will delete this executable automatically. So it would be better to zip it first and then transfer it to the Windows virtual machine. Okay, otherwise, we cannot continue. Anyhow, I have already transferred to the Windows virtual machine. So now we can, we can take the same steps. Okay, so now I'd like to, so how to do? Let me. We can, I think. So how to do? We need to, first of all, we need to see whether this program is vulnerable to buffer overflow. So how to do? Let's delete existing code. And again, we change this address back to the Windows machine, but the port number is different. This case is another one. We can copy and okay, and if you connect, I think we can run it. And we can, for example, we can run it. BB, okay, it's the same. So now we can run it one more time. Okay, let's go back to PyCharm editor. So how to do? Size, maybe I can define it here. This case, the buffer is much smaller. To save time, I'd like to define to 2. Okay, you will know what I mean when we get it there. And we can use the Y true, and so the payload size, and we can send the payload. Also, we can receive data from the target machine. Of course, as before, we need to have the try and except construct to capture the exception if anything wrong, and then it means that we have already catch the buffer overflow. Okay, so we can print something is wrong at this location. Then we can close, and then we can exit from the program, and also we can send something like print sending data in bytes. Okay, however, we also need to put x00, and then I think we can size time sleep 1 second. Okay, the same as before. So now we can run it, exploit. The 10 bytes. So how to do? Let me the 10 bytes. So I think we can create the payload with this Unity create, and we can set it to like 20, and we can copy and paste. Of course, in this case we can delete. Okay, save, and so now, of course, in the meantime, we need to launch Immunity Debugger. So now we can open the beta version, click, it's running, and then we can run our exploit. So then we can copy this EIP address, copy selection, and we can calculate its offset. We can calculate ms pattern offset. So the offset is 13, much smaller. So it's 13. So next, of course, also you need to find better characters besides 00. But to save time, I'd like to tell you we can't find anything else. So I'd like to skip this part. So next, we need to find the EIP address. Let's go back to here. We can use the same way. Mona modules. And this one is vulnerable. You know, the executable itself So next we can use find xff for done better xe, but nothing found. So instead we need to find the push ESP. Push ESP, I can remember. So what's that? Push ESP. So 44C3. 54C3. Run it, and we find not found 44 and C3. So I think we need to find another type of, the assembly instruction. After all, this is a different version of executable. So how to do? So the jump ESP doesn't work. And also push ESP doesn't work either. So what else? What else? What else? I think we need to find this one, call ESP. In most CTF machines, we can use this instruction. It's enough. But in this case, we need to find other types of instruction. So FFD4. So now let's find this, because we need to use the operate code rather than the instruction itself, D4. So this time we find one pointer we can copy this address. We can, not this one. Oh. We can copy this address. Yeah, this one we can copy and go to, I think we can go to the PyCharm. So next also we need to create the shellcode, Venom. And I'd like to skip I'd like to save time of this video because the steps are the same. So I'd like to directly generate the payload or shellcode for the Linux or the target machine. Okay, so I think we can, port number, I'd like to use different port number, like 8000. And like Python. So it's created. We can copy this shellcode, although the variable name is buffer, but you know what I mean. Okay, so we can put over here and 13 and should be EIP. X13, X15, X 52. And also, I think it's better to put some non-operation code, right? X90. And then should be the buffer or shellcode. And the address should be IP address of the target machine. We can remove this one. We can save. I think that's all. Next, we can set up the listener on the Kali Linux, waiting for collection. So now we can run our code. Okay, we got a collection. Beautiful. ID. You know, this is root user. Fantastic. Then we can grab the flag or proof. So I think that's pretty much it. I'd like to see you next. Bye. Have a nice day, please.